Vaccines protect us from disease. It's a remarkable concept when you think about it. A quick visit with a doctor, a shot in the arm, and voila. Within just a couple of weeks, you've gained immunity to some of the most dangerous infections on the planet. But because the procedure is so simple, and the immunization itself takes only seconds, it's easy to take for granted the amazing science that's at work during and long after vaccination. Indeed, before you've even rolled down your sleeve, a complex chain reaction has begun inside you, a biological process that will help you win life and death battles that you'll never even know you fought. So how does it all happen? What really goes on inside you? And how can something so simple have such a lasting impact on your health? This is how vaccines work. Zoom in. Further. 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 There. These are antigen-presenting cells. They're virtually everywhere inside us. Their job is to patrol your body, scanning for potential threats. Anytime they find something suspicious, whether it's an allergen, a cancer cell, a bacterium, or a virus, they discreetly collect information about their suspect and bring it back to their headquarters, the lymph nodes. At HQ, B cells and T cells eagerly await reports from their antigen-presenting friends. These cells are trained killers. B cells produce antibodies, custom Y-shaped weapons that are purpose-built for neutralizing threats, and T cells seek and destroy any cells that have already been compromised. T cells and B cells also work together to facilitate antibody production, whatever it takes to get the job done. Regardless of the evidence or antigen that's brought back to HQ, our body's B cells and T cells will line up to measure the task at hand. Some won't have what it takes. They're better suited for taking out other threats. But others will have the exact set of skills required for the job and spring into action. Off they go. Over time, these compatible cells will multiply, refine their infection detecting and eliminating skills, and persist in your body so that the next time similar antigens are found, they can act swiftly and decisively. It's why you only get some infections once, like chickenpox. It's not that you never encounter the causative virus again. It's that your B cells and T cells have become experts at neutralizing it before an infection can happen. Other viruses like those that cause influenza or COVID-19 mutate frequently in order to disguise themselves from the immune cells that have been trained to recognize them, which is why seasonal infections can occur and why annual boosters are needed. But what happens if you're exposed to a pathogen that your B cells and T cells have not yet been trained to recognize? In these cases, your immune system must train itself to recognize and kill the invader after it has already started to attack your body. This process is relatively slow, which gives the invader an opportunity to spread through your body unchecked. This can make you really sick, and depending on the bug, can sometimes be fatal. But this is where vaccines come in. Instead of needing to become infected first in order to train your immune system to protect you later on, as in the example of chickenpox, vaccines prepare your immune system to prevent future infection without needing to become sick in the first place. Now, if, or more like when, you come into contact with something that you've been vaccinated against, you can drastically shorten that B cell, T cell song and dance and cut right to the chase, neutralizing the target before it can cause infection. There are many types of vaccines, including live attenuated, inactivated, mRNA, and viral vector, to name just a few. And while they all use different tricks to catch the attention of your immune system, they all fundamentally perform the same function. They're a how-to guide for your immune system, a training manual that primes it for action in times of emergency. That alone is amazing. But the social impact of vaccines is arguably even more impressive. See, when you take steps to keep yourself safe from infection, you're taking steps to keep others safe too. You can't spread infections that you don't have. And the real magic happens when enough people embrace this logic. When large portions of a given community receive the same vaccines, diseases have nowhere to go. Say, for example, a measles infection occurs in your neighborhood. If everyone around the infected individual has been vaccinated against the measles virus, then the virus hits a wall. It fizzles out before it can reach new hosts. This is often called herd immunity, and it not only prevents outbreaks, but it's also how we've completely eradicated diseases like smallpox. Importantly, herd immunity allows vaccines to indirectly protect even those who cannot get vaccinated or who do not respond effectively to vaccines, the most vulnerable among us, like newborn babies or people with weakened immune systems. So yes, vaccines are a scientific triumph. A single shot can supercharge millions of immune cells within us. But vaccines work best when we all take part. Because the moment you roll up your sleeve, you become part of a broader immune shield that keeps our communities safe from disease.